Azure Data Explorer and analyzing real-time data. So this is mostly a session where I want to share my learnings of IoT projects. I did quite a few of them in the last 3 years. And that's here the biggest one, Electrolux. It's a worldwide manufacturer of household equipment. And there we connected more than 20 manufacturing sites worldwide in real time with the Azure Cloud using Azure Data Explorer. So that's where I got the most of the learnings. We did quite some energy savings over there by reducing, for example, the gas consumption of the furnace ovens. Just to make sure that my timer is on. Yes, a little word about myself, Toon Vanhoutte. I'm from Belgium, CTO at Noest. Noest is a local company in Belgium, a real Microsoft community where with local people and the local companies around it, we try to build solutions that make people's life easier and more efficient. I've been awarded as an Azure MVP, mostly thanks to my contributions in the Azure integration space. But integration IoT, for me, it's very closely related, so that's why I'm also quite active in there. I'm a dad of 2 kids, 2 sons, Oliver and Brent, 4 and 6 years old, and I'm a big cycling fan. You can maybe see it on my shoes, and if you're from Belgium, you just don't have another choice. So IoT projects, what are the typical challenges that we face there? Of course, ingestion of a lot of data, a high velocity of data. So that's quite a challenge, of course. You start maybe with 10 devices, you end up with millions of messages a day that need to scale, of course, that ingestion. End users expect, of course, fast dashboards, fast applications. They don't care if you need to query billions of data. It's all about speed nowadays, so the end users are not concerned about your job as a developer. And the queries sometimes tend to be complex in IoT scenarios because you don't want to see only a stream of data, you also want to have aggregated maximums and so on over certain time periods, so it can get rather complex. And in IoT projects, you also need to take care about hot and cold data. So cold data, more historical data, typically also needs to be available for query. Could be maybe a little bit slower, these queries. And the hot data, typically, I think 7 to 30 days needs to be available at a very fast speeds. So during the last 5 years, I did quite some assessments and audits also on customers who started IoT projects. And these are a few attempts that I've seen before. One customer started off with table storage. So the events were coming in on event hubs over there, and they had an Azure function written that stored all the telemetry data actually in Azure table storage. Table storage can handle that from an ingestion perspective, no problems at all. But from the query side, it was not, of course, optimal. If you wanted, for example, to display the pressure of a certain valve for the last hour, that was still easy feasible. You just query on the row and partition key. With the row key, you had to play a little bit with Unix time. Then it worked out. But from the moment they tried to have aggregations, what was the maximum temperature of that device during a week, table storage does not support anything to do these queries server side. So they had to fetch all the data, do it client side, and so that was too slow. So that customer, they started creating background jobs for every aggregation that they need to calculate. But of course, every time the business had a new request, it was a new background job that they had to initiate, a new SQL table to store the results in, so it was actually a big drama under the hood. And so table storage, good for ingestion, but really not a good option for the query side of things. Another option that I see frequently being used is Azure Cosmos DB, so the NoSQL database of Microsoft globally distributed. It's definitely a good option, but also there you need to take into account a few things. The first 2 queries are quite easily feasible, but with Azure Cosmos DB you have also the concept of partitioning, so the physical partitioning. Luckily, at Cosmos DB team, I think 1.5 years ago or something like that, they introduced the concept of hierarchical partition keys, where you could go up to 3 levels of partitioning. And in most IoT scenarios, that would be typically your highest level would be your tenant ID, if it's a multi-tenant scenario, or your factory ID, for example, and then the device ID would be typically a next one. Be aware, for one partition, you have a maximum of 20 gigabytes. If you go over that limit, you need to re-architect and redesign your stuff. So that's not easy to deal with, definitely if you want to also deal with historical data. Queries like the most active device per tenant or the last known value per sensor, they are feasible with Cosmos DB in that way, but they will be quite expensive because they would be cross-partition queries who are quite expensive over there. Expensive from a financial perspective and also from a time perspective, they would be rather slow. Definitely the last known value is a very known IoT query. I want for every sensor just to know the latest value that they sent. That's not easily feasible with Cosmos DB unless you go for the change feed option, you read the data again and store it in another format. Another challenge with this approach is the ingestion towards Cosmos DB. Cosmos DB has also failures, of course. Network could drop, there could be something in the internal engine. So you need to make sure if you don't want to lose any message, that your Azure function, that you just don't use the default bindings, but that you make it reliable. You need to do retries and so on, put messages aside, try to ingest them later on. That's not that easy, to be honest. It's good to make this work for a demo, but once it starts to scale at hundreds of messages per second, and you need to also write that complex logic only with an Azure function, it's not easy to do. So that's why my preferred option for these kind of projects in Azure is using Azure Data Explorer, of course, otherwise the session would have been named differently. And one of the main features there is the managed ingestion. So if your data is in Event Hub, you just couple it, you connect it to your Azure Data Explorer, and all the ingestion is handled for you. So you don't need to write a single line of code. All the retry mechanisms are handled by Microsoft. And it works for 200 messages a day. It works for 200 million messages a day. And that's very nice. Some people say, it's rather expensive Data Explorer. Yeah, it's more expensive than Cosmos DB or table storage at first. But if you take into account all the hours and days that developers are trying to make that ingestion pipeline more reliable, I think it's rather cheap. So all these queries are quite easily feasible within Data Explorer, and I show you some examples, of course, in the demos. So first, a little bit an introduction of Azure Data Explorer, and then we go to the features that it offers, and at the last part, I want to focus on the performance optimizations. So a little history. Data Explorer started actually as an internal tool at Microsoft, being used by the Azure SQL DB teams, and also Skype for Business at that time. They replaced their whole Splunk platform by the internal Kusto project. It was codenamed Kusto at that moment in time. And in 2019, actually, they made that internal service also available towards their customers. So Azure Data Explorer went general available. Fantastic service. Maybe you've also heard of used time series insights. Azure Time Series Insights was actually a little bit the little brother of Azure Data Explorer, but this has already been decommissioned by now. And Microsoft Fabric, the whole new thing in data world and data analytics, the whole SaaS platform that Microsoft is pushing. Also there is a real-time analytics component, which gets a lot of attention by Microsoft. And under the hood, that is also using Azure Data Explorer. So it's being used all over the place. So it's quite a mature service. So what is it exactly? It's a big data platform. So it is about high velocity, high volume, and high variance of data. An analytics platform, so you can query it like it would be almost a relational database with your joins, filters, aggregations, and so on. Cloud platform, that's what I like the most. You just spin it up, you have your monthly fee, and you're good to go. It's a very reliable service. Never had real outages in the last 3 years. It's really optimized for these fast and ad hoc queries on time series data. So time series is important, of course. Your data needs to be a data stream and not just relational data. Let's have a look a little bit under the hood. First of all, centrally, we have the Azure Data Explorer cluster, the engine, who's running actually just on virtual machines with local SSD. The local SSD is used for hot cache, and the cold data is stored on Azure Blob Storage or Data Lake Store. Of course, it's an Azure service, so through the Azure portal or ARM, the Azure Resource Manager, the templates or the CLI, you can, of course, completely manage your the management plane. There are quite a lot of connectors to ingest data into Azure Data Explorer, and there are a few of these connectors who have active connections, so where you have real-time data ingestion by default handled completely by Microsoft. So you have IoT Hub, Event Hub, and Event Grids integration. So it means if you have events or messages entering on those messaging systems, they could be automatically ingested in your Azure Data Explorer. The Event Grid is also used to ingest data that is stored on a storage account. Because when you put data on a storage account, under the hood, Event Grid will be used to notify Azure Data Explorer, hey, there's a new file, you could pick it up and ingest it in your system. You can reach out to external data, we come to that in a second, and there are quite some connectors to build dashboards and so on top of it. All the data is also available through SDKs, APIs, so you can build your custom solutions on top of Data Explorer. So what are the main advantages of using Data Explorer? The first one I really like is the fully managed ingestion. So you have a one-time ingestion. If you have a bunch of historical data, you could just do a bulk insert in your Azure Data Explorer. It will take a while, but you manage. But the most important feature for me is the continuous data ingestion, where you can say, okay, here is my source data, Azure Data Explorer, take care of it. In my demo, it will be Event Hubs. And if you do the data ingestion, you have two options. The continuous one, you go for streaming or for queued. By default, I would say go for queued. It's more optimized for that high volume of data, but it goes a little bit slower. It's more in batch that it works, so less resources are consumed, but you have a little bit of a delay. If you really require sub-second latency, then you should enable streaming on your data ingestion. And that's really optimized for low latency, yes. It's really about seconds. I think if we look at the Electrolux case, so the data was on premises, so we did the OPC-UA connection, then a local MQTT broker. That one was forwarded to the cloud. And then in Data Explorer, we saw an average delay of 3 seconds over there. So it was quite good, yeah. So between 3 and 6 seconds, that's what you could expect over there. From data formats, yeah, almost everything you can imagine is supported. JSON, Avro, Parquet, TSV, PSV, whatever. Also the log files of the WC consortium is supported. If you want to query the data, you cannot use SQL. Everybody almost knows SQL, but it's KQL, the Kusto Query Language. That's where it comes from. But if you're familiar with SQL, I think you get up to speed very well with this. GitHub Copilot is also very good at writing Kusto Query Language queries. So definitely look it up. It works with the piping system, so every time you have your pipe and your statement after it, your data sets get smaller and smaller. So the output of your previous pipe gets ingested actually in the next part of your query. This is a very nice feature, and I learned it thanks to Sander. There's also a link to his very good blog about this. So it's about inbound transformations. So if you have IoT data, typically JSON files, CSV files, whatever that are coming in, the data format is not always optimal. So what is a good pattern in Azure Data Explorer, that you just dump your data into a raw table, where you just dump the JSON as is, and then you write an update query. That's actually a query that can run continuously on that table to project that data into your destination table. That destination table is then the table that will be used for your dashboarding and your applications. And so you have a kind of a split between your inbound, your ingestion, and your outbound. So you could, in that transformation, in that Kusto query that you write to copy data from the raw table into, this case, telemetry table, you could set the right data types for your fields. You could clean up some default values and these kind of things. You can calculate times and so on. So you can clean up your data so it gets in a consistent manner in your telemetry table. You could even do the routing if you say, okay, on my IoT hub, I have both heartbeat data and telemetry data, and I want to split that out. You could definitely do that with those update policies. So you almost have no delay if you do this. So this is very powerful just to make sure if suddenly your input format changes, yeah, you just have to update a little bit your update policies and all the rest remains working. Otherwise, you're directly tied to your inbound format, which might be dangerous in IoT scenarios. Or maybe currently you only support sensors of type X, and tomorrow you have another type. This is perfect because then you can just handle that mapping complexity and the cleanup complexity with these update policies. Hot and cold storage, that's one of the big advantages of Azure Data Explorer, is you could query very fast and you could query a little bit slower on historical data. But the query is the same. So you don't need to have different technologies for cold versus hot data that you query. You can very easily set the caching policy with that statement there. I can do it on the highest level, cluster level, database level, or table or view level. So you can on every level specify how long should my data be in the hot cache. When that hot period is over, your data gets automatically moved to the colder cache. It is still available to query, but it will be a little bit slower. The hot cache for Azure Data Explorer is actually the local SSDs that are being used and a little bit of the RAM. The cold cache is a blob storage or Azure Data Lake Store on top of blob storage. Retention policy is also a good one. So the caching policy that we had previously here was really about hot versus cold. Retention policy is about just getting rid of your data when it gets too old. You could, for example, apply this on this raw table. If you say on the raw table there, I don't need that data a lot. This is just for ingestion purposes. After 1 day, we can remove that data. Then you can apply on that table a retention policy where you say, okay, after 1 day, this data should not be available anymore for query. You could do it with a soft delete version. So you can still say, okay, maybe I'm not 100% sure, so I want a few days additional to recover my data if needed. Again, that policy can be on database level, table, or view level. External data, that's quite important also because often your IoT data only contains unique IDs, typically GUIDs that are being used, but to know then this device ID. And then of course advanced analytics, optimized for these time series data, so you have regression analysis, anomaly detection, forecasting. For a few of these things you need to have the mathematical backgrounds, which I don't, so these complex functions are often not easy for me to understand. But this query here is a very common one that is used. It's the summarize by bin. And the summarize is a little bit the same like the group by in SQL, where in this query actually we say, give me the speed for this device here for the last day. And I want to have the average speed per hour. So I summarize by timestamp per hour. And that's calculations which can be quite complex, but happen quite rapidly with Kusto. And then last but not least, of course, you need to visualize your data. So there are a lot of out-of-the-box connectors. Grafana is a quite popular one to connect it to your Azure Data Explorer service. And of course, everything which is custom. So you have SDKs in Python, .NET, whatever, to connect to your database. So, little time for a demo. So, 2 weeks ago I started my demo. So we have an Azure Container app running, just simulating data, random data, not 100% random, there's some pattern in it. And it's sending data through MQTT to the event hub, to the IoT hub. IoT hub, under the hood is actually an event hub. So under the hood, this data just gets flown into the event hub. And from there, the data gets automatically ingested in Data Explorer. And then just by opening the query pane in Azure Data Explorer and using Kusto Query Language statements, we will query the data. So I will show you a little bit here this container app, the IoT hub, and then we go immediately to here. So this is my, you see the resources that I've deployed in Azure. And then the first resource is my container app over here. This is the log stream. So normally it's sending 1,400 messages on average per 10 seconds. So you should normally see it increasing every 10 seconds, a new message should arrive. So it's all configuration-based, multi-threaded, that this thing is just sending messages. So this is just a container app running at one instance of that container. Then we have the IoT Hub with the daily message limit of 24 million. Of course, my Azure consumption should be a little bit under control. But you see here, for example, today we used already 6 million messages. And see here the device-to-cloud messages that have been sent. I only have one connected device because, I'm simulating everything. So from an IoT Hub connection perspective, it's just my one connection that I have. This is then the database in Azure Data Explorer. You can here query, but here the most important thing are those active data connections. So you see here that I have a data connection with my Event Hub using system-aside managed identity. So from a security perspective, this is also good. So just by configuring this, you can easily do this with Kusto Query statements. You just say, okay, this data needs to land in this table, in case my raw table, and for the rest, Data Explorer takes care of it. And let's now start querying that table. So this is just the online query pane that you have for Data Explorer, but there are other ways to do it. So the first query I want to run, I just select the query, I click Run. And here at the bottom, you see the time that it takes. It's a developer instance, so sometimes it's not 100% powerful. But you see here, we have the IoT Hub device ID. This is the raw table, so the table where everything lands in. And I have only two columns, the IoT Hub device ID and then the raw payload. So this is just the JSON message that I receive from my IoT device. I'm just dumping this as a raw JSON. That's called the dynamic type in Azure Data Explorer. I just dump it into my raw table. Of course, querying this would not be good because this JSON format could change. And querying on JSON is, of course, not optimal. So that's why I wrote an update statement which copies and transforms the data from this telemetry hot row to the telemetry table. So if I query that telemetry table, like here, you should see this is the data that I have over there. I have a device ID, a GUID, timestamp, a tag name. A tag is a sensor value, a sensor, unique sensor, and then the tag value is the value of that one. You see, this is a string value. I have also a real value if it's a real or a geo version. So there's longitude, latitude, and so on also available. So let's have a look at the number of tags. I just do telemetry pipe count. And then this will count the number of messages. So I'm now at 330 million messages. And you should see it increasing every second. And so you see it's constantly increasing with a few thousand messages per 10 seconds. So every time I do the query, you see the field update. So it's really real-time data that we are querying at this space. I can count the number of tags per device. So I do a summarize, a group by device ID, and give me the count of these tags. So let's run this query. And this should give us an overview, if they want to, of course. Yes, there we are. You see all the devices and the counts. I can redo this query, but I just add render bar chart. So this will render my results in a visual manner. So I can easily explore the data, see maybe if there are some exceptional active devices. You can also still see the data which is underneath this graph, so you have both available. I can also show the distinct tag names. So what kind of devices are sending now data for the last 100K of 10K I have. So these are all my devices with their respective IDs and their tag names, temperature, speed, the modus that they are running in, the location, and whether they are active or not. But of course, the device ID, we like to see, of course, the name of the device, maybe the location of that device, maybe the tenant it belongs to. So all that information in my demo is on blob storage. I just have a JSON file with all my metadata, which links actually those device IDs with the real world. So I made an external table of that. So now currently I'm querying actually a file on blob storage, but for me it just feels like it's not a table. I query it like this, and you see I have my device ID, but also device name and tenant. So I have two tenants, Nust and Microsoft over here. So let's now join these two queries. We had here this distinct tag names and device IDs. Let's just join them with our master data, with our asset hierarchy, and then we have actually the same query, but now with more human-friendly. We know, okay, these are the devices that we have. They belong to this tenant, and these are the tags that they are sending. All right? Then, of course, we want to see the values too. So in this case, show the device temperature for the last 20 minutes. So with this between function, you can go for the last 20 minutes. With the project, you decide what you want to return. It's a select statement, actually. We order by timestamp, and we render it in a bar chart. And then you see all the data within this 20 minutes time slot. The average speed per hour, that's also a nice one. Because, of course, if you want to show data over longer periods, you don't want to show every single entry. Maybe you want to start aggregating if you want to show the data over a period of 1 day or 1 month. So that's why this summarize by duration is very nice. So you see here at 9 o'clock we had a maximum speed of almost 90, minimum of almost 0, and an average of 43. And to be honest, this sensor is just configured randomly to always be between 0 and 90, and just goes randomly up and down the whole time. So you see the random is quite in line with the statistics. So you see here, just for every order, we have the minimum, the maximum, the average, and the count. So that's very nice. We have also engine cycles. That's a little bit more complex, this query. I will not explain it completely in depth, but this is using one of these forecasting capabilities that you have. So the red line is actually our original data, which stops where my cursor is now. And with the series decompose forecast function, you ask actually to Azure Data Explorer, please find a pattern in this and let me know how the pattern would continue. And this would be then the forecast in blue. So these are complex functions. I don't understand them all, to be honest, because my mathematical background is limited in that space. But if you're into machine learning and these kind of things, you will definitely understand these functions a lot more. Also, longitude, latitudes, GPS positions are also very popular in IoT scenarios. So just want to show you that I also have the longitude, latitude of many of these devices. And you could do even geofencing with that. So this is here, a geofence around the office that we have. And I have a virtual truck just constantly riding the same circle. And I just ask here, maybe it's not the purpose to understand the whole query, but actually here we say, okay, where my longitude, latitude is inside my polygon, yes, and where the previous is not inside my polygon, or the next one is also not inside my polygon. So actually, then we determine the moment where you went from outside the geofence to inside the geofence, or the other way around. So if we run this query, we will find all the moments during that period, I think it's the last 8 hours, where the truck entered or left. So you see, the square that I took, the polygon, was almost this one. So here we always enter, and there we always exit. If you look at the table, you will see at that moment the truck entered, the polygon exits, and like that. So historical analysis, or quite real-time analysis on this geofencing is possible. And then just a last funny thing, if I want to check the route of a specific truck during the last, what is it here? I just say take the last 600 values. You see that we have a marketing truck driving constantly the name of Nust. So, all right, let's move over to maybe the most interesting part. Is how can we now optimize performance? Of course, take the right cluster size, very important. If you ask Microsoft for help and they see that you have a developer instance, they will just stop. So always go for a production ready instance with SLA, otherwise you will not get any support on your performance. Select the right SKU type. Of course, you have different dimensions, and you have clusters who are optimized for compute, others are optimized for storage. So depending on your needs, you need to use the right one. If needed, you could even set up a leader-follower pattern where the follower cluster keeps in sync with a slight delay, and that one you can use, for example, as a read-only instance. I never had to use it, to be honest. With one cluster, you can really deal with a lot of data. Table design, of course, like with SQL Server, also ADX, you have a few optimizations. All the details you can find on the QR code over here, but the most important ones are maybe listed over here. First of all, be careful with the dynamic type. The dynamic type is a JSON value as a column. If you have fields that you query quite a lot, don't put them in a dynamic type because it will not be optimal. On the other hand, you need to make your tables as narrow as possible, so as few columns as possible. So if you have fields who are not accessed that frequently, put them in a dynamic type just as a JSON value. Your IDs should be strings. It's better for partitioning and indexing, so don't make them numeric. And if you're dealing with numbers, a decimal is much lower than reals. So only use decimals if you really need that precision. And joins and Azure Data Explorer, it's not the best marriage. So if you could avoid CPU-intensive joins by deduplicating your data and denormalizing it, I think it's a good idea. Because having more data will require less resources than having CPU-intensive joins. So maybe think about denormalization, deduplication of your data. Partitioning, like with any big data platform, partitioning is important. There's quite some advice of Microsoft about it, and they say that they actually support 3 scenarios. The first one is if you have frequent filters, if a lot of your queries constantly contain the same filter. A typical example would be where tenant ID equals or where factory ID equals. That would be an example to do partitioning on that filter. This is only supported on string or GUID values, so that's important. And Microsoft gives you also an advice, make sure that you have enough distinct values of that tenant. If you only have 10 tenants, it doesn't make sense to start partitioning by tenant ID, because you will have more overhead of the partitioning than it gives you advantages. The same is true for frequent aggregations. So if you're doing aggregations quite frequently on certain values, also there it can be recommended to do the aggregation. For example, per device, a lot per device or per sensor ID, you will do a lot of aggregations, so you can also partition on that. There, the recommendation is to have at least 1 million distinct values. That's a guidance by Microsoft, because they see if you have not enough sensor data, it's better not to partition and just keep everything in one spot, because it will just be faster. And then the one I'm personally using the most is the out-of-order ingestion, because by default, your data gets partitioned by the ingestion time, at the moment when your data gets injected into the cluster. But of course, reality is sometimes that there's a delay in it, or maybe the data got stuck along the way and got only imported later. Also, many of my projects, they have a hot path and a cold path. So the cold path is maybe the data is only ingested once an hour or once per day in that case. So of course, in such a scenario, you don't want to partition by ingestion time. I want to partition by the real event time, by the time that is really inside my IoT message. So that's really one I'm using quite a lot. Also there, if you do partitioning, make sure that your compressed partition size is larger than 1 gigabyte. That's another recommendation by Microsoft. If you're not meeting that requirement, maybe it's too much overhead for you. So you see, only the partitioning is needed when you have a lot of data. Otherwise, you can go ahead with native Data Explorer. This is, maybe if you want to only remember one thing of this session, I would recommend here the materialized view. That's actually a way to expose an aggregation query over a source table. The one I'm using the most, and I will show it in the demo, is also the last known value per sensor. That's quite an intensive query. because the last known value could be of 1 year ago. So how can we build this? With the materialized view. How do you create a materialized view? Very simple. You say to Data Explorer, create a materialized view, and store your data already over there. So the performance will be very fast, and your data will be fresh. So Azure Data Explorer is typically every minute updating your materialized view with the results of your query, but it will take also into account the part that was not materialized yet. So they will query both sides, your materialized view and the fresh data, and combine that in your query result. So it's much cheaper to do this instead of running your complex query on your source table. I will go a bit quick because I see I only have 5 minutes. So this one, optimized queries, just be aware that there are quite some optimizations you can do. Check out maybe the QR codes. Caching is also possible. So if you have a query, you can say, okay, I want the results to be cached. So the next time I execute the same query, you will get the cached result back. So that's a very important one. And troubleshooting. Next to your data set, you get also your statistics back. So there you can also a little bit see how much data came from the cache, how much data came from the cold and the hot data, and so on. And troubleshooting, you have a command, show queries, which shows you all the queries that have been executed in your cluster. So there you can, of course, do queries to see which one was the slowest query, which are the most CPU-intensive queries. So let's go for a demo on this. I have here my query. The last known values of all sensors. If I run this, this will take, I think, about 1 minute. So what I do here, I do a summarize, a group by per device and tag name. And I say, for each unique tag, take me the arguments where the timestamp is the maximum, so the latest timestamp. And for that, the star is just give me all these arguments. The rest is just joining over my external table and letting the query know what I want to select, but the complexity is over here. Now I think I have to still talk 30 seconds before the results arrive here. But you see, this is very intensive because, in the end, my last known value could be of 20 days ago. So this is quite intensive for Azure Data Explorer to solve this. So bear with me. One question, yeah? Yes. What about everything UTC in Data Explorer? Yeah, that's a good question. Yeah. So you see here, 65 seconds. If I now do the same query on my materialized view that was prepared, 1 second, and that's even very slow, to be honest. Mostly it's around 200 milliseconds with good network. I think here a little bit less. And this is up to date. If you see, the data is constantly up to date with the latest version. If you even don't care about the up-to-dateness and you say, okay, my data can be maybe stale for the last minute, you could even use this function here, materialized view, to only query the materialized part and not to take into account the delta that still is not materialized. So if you have this one, you see it takes 300 milliseconds, and if you even do this, the pipe consume, then you will not return the data set. You will only execute the query server side. And you see, normally we go even under 100 milliseconds without the network hop. So this is very fast because Azure Data Explorer did the pre-calculation of my query up front, but still takes into account the new data that arrives. So that's very nice. You can query hot and cold storage with one single query. So this one is querying hot and cold because my data older than 2 days is in the cold storage. I can set my query scope to hot cache, so I only query the hot cache, and then of course I have a result set which is less. I will skip this one just for the sake of time. And then here we have show queries. These are my 10 slowest queries. And so you can start investigating, and you can then group by maybe by CPU usage. If you see in your cluster my CPU is quite intensively being used, who is causing this? Which application or which user is doing these queries? It can be often Power BI that is doing nasty queries in the back. All right. So let me end with a few challenges that I see, because of course this was a little bit a good news show, also fancy stuff that you can do, but it comes also with a few challenges. First of all, Azure Data Explorer is designed for append-only data. So you can delete data, but it's not designed for that. It's quite an intensive way to do it. Updating data is not possible. What you could do, if really needed, you could insert a new line and then write a materialized view to say, always take the latest version. But you see, it's not designed for that. You can work around it a little bit for certain use cases. But if you have use cases where you need to update your data frequently, it might not be the good option for you. Another challenge is eventual consistency. You give your messages, your data to Azure Data Explorer, but you will never know exactly when it will become available for query. In SQL, I insert it and I query 1 millisecond later, it's available. This is not the case with Azure Data Explorer. So what did we have at Electrolux? We had real-time analytics, which says, hey, we have an anomaly. We did send a notification to the receiving application. That one called our API, which under the hood was using Azure Data Explorer. And there we said, the data is not here yet. So it's like getting a notification that you have a new mail. You go to your mailbox and the mail is not there yet. And you press F5 and the mail is there. So there's a slight delay that you don't control because, of course, of that eventual consistency, which makes it, in some cases, hard to work with. So you need to be aware of that. And by default, there's no point-in-time restore for Azure Data Explorer. I think that makes a little bit sense considering the complexity of the system. But of course, if you work in enterprises, it's often the requirement to have point-in-time restore. You can achieve it with a continuous export and make sure that your import scripts are ready. But it's a DIY solution sometimes, so it's not always easy to sell that in the bigger enterprises. So if you're interested to get started with this, I think two very good learning sources. On the left, you have ADX in a day, a GitHub repo with a lot of examples. You can use the free clusters for that. And the Kusto detective agency is a fantastic way to, it's not Data Explorer specific, but really to learn the KQL language. So fantastic gamification over there. I keep it on for maybe a few seconds here. And for the rest, thanks a lot for joining this session. It's quite a niche topic, but still happy to have a few attendees over here. So I hope you liked it. No time for questions anymore here on stage, but of course, you can always come talk to me right after this. Thanks a lot.